Welcome to This Explainer. Today, we are taking some seriously dense sports science and transforming it into actionable coaching insights. We are unlocking what is basically the ultimate athletic currency, power. We're going to draw directly from the National Strength and Conditioning Association's comprehensive research on the topic, and we'll be looking at everything from molecular muscle mechanics all the way up to multi-year training periodization. Let's get into it. All right, let's kick things off with a pretty fundamental question. Think about it. What actually separates the ability to slowly, agonizingly grind out a massively heavy back squat from the ability to explode off the floor for huge slam dunk, or to completely change direction in a fraction of a second on the rugby pitch? Well, the difference isn't just about the sheer force you can create. It's about how incredibly quickly you can express it. Here's the thing. Power isn't just a vibe or some subjective feeling. It's actually a strict mathematical construct. Power is literally the rate of doing work. It's calculated as the force you produce multiplied by the velocity at which you move. Think of it like this. If you have high force but zero velocity, like pushing against a solid brick wall, you've got zero power. On the flip side, if you have high velocity but no force, your power is also going to be remarkably low. Maximizing athletic power is all about finding that absolute perfect interception of those two variables. To make sense of all this textbook science, we're going to follow a clear roadmap. First up, the nature of power. Then, how to assess power. And finally, the periodization playbook. Starting with Section 1, the nature of power. Think of your muscles as, well, basically a giant molecular electric motor. And just like a motor needs a spark to run, human movement requires electrical action potentials crossing the neuromuscular junction just to ignite that movement. Neurotransmitters get released, calcium floods into the muscle fiber, and boom, the whole system is primed and prepped to generate force. Once that signal hits, energy is derived from ATP hydrolysis. This allows millions of microscopic myosin and actin crossbridges to attach, swivel, and detach. To put this into perspective, a single crossbridge generates about 4 piconewtons of force. So get this. Squatting a 100-kilogram weight requires roughly 245 trillion of those crossbridges firing in a perfectly orchestrated sequence. That internal microscopic force is what eventually moves your whole macroscopic body. Now, this is where it gets really fascinating. Our muscles act totally differently depending on what they're doing. The force-velocity relationship completely changes based on whether a muscle is shortening or lengthening. When a muscle shortens quickly, which is a concentric action, force actually drops. But when a muscle lengthens quickly under tension, an eccentric action, force spikes before it plateaus. This eccentric force often comes from the forced detachment of myosin heads. And that's exactly why eccentric training can lead to such intense muscle damage and soreness. But it's absolutely vital for absorbing force in sports. So let's de-jargon the math of force times velocity for a second. Science shows that athletes often generate the absolute highest peak power when moving a load roughly equal to their own body weight. Think of a simple unloaded jump squat. You are operating at an optimal midpoint. You have moderate force because you're fighting Earth's gravity by moving your own mass, and you have moderate velocity. A maximal heavy squat gives you high force but low velocity. A jump on the moon would give you high velocity but very low force. But jumping right here on Earth with a 1.0 times body weight load, that creates the ultimate sweet spot for peak power output. Let's keep rolling into Section 2, how to assess power. For decades, coaches relied on indirect math. They'd use equations like the Bosco or Harmon formulas, basically predicting power based entirely on jump height or flight time. But today, direct assessment is the absolute gold standard. Utilizing force plates to capture ground reaction forces, alongside linear position transducers to track barbell velocity, gives us the exact net system power. No guessing involved. But hold on, for any of that direct testing to actually mean anything, you have to strictly control your variables. You need consistent equipment, standardized instructions for the athletes, and you absolutely have to test at the same time of day with the exact same warm-up protocol. If an athlete is dragging from a heavy leg session the day before, or if the temperature in your facility is fluctuating wildly, your data is literally just noise. True reliability requires rigorous consistency. Okay, so you've got your clean data. Now you need to compare apples to apples. When you're looking at athletes of different sizes, you have to standardize the numbers. The most common way is ratio scaling, just dividing their power output by their body mass. Pretty simple, right? Well, you have to be careful, because simple ratio scaling can sometimes mathematically biased against the absolute largest or smallest athletes on your team. That is where allometric scaling comes in. It uses complex exponents to theoretically remove the effect of body size entirely. Though, admittedly, it can be a bit trickier to apply in a day-to-day coaching setting. A truly game-changing way to present all this standardized data to a coaching staff is the Z-score. Instead of just throwing a spreadsheet of raw wattage numbers at a head coach, a Z-score instantly tells you exactly where an individual athlete stands relative to the rest of the roster. It calculates how many standard deviations an athlete is above or below the team mean. It's brilliant because you can instantly spot who's lagging behind in power development and who is primed and ready for advanced progression. Which brings us to our final section, Section 3, the periodization playbook. The entire foundation of periodization comes down to Hans Selye's general adaptation syndrome. Honestly, it's basically the hero's journey, but for an athlete's body. First, you introduce the stress of training. This triggers the alarm phase. Fatigue accumulates, and surprisingly, performance actually drops. But then the body fights back during the resistance phase, adapting to the stress. If you time it perfectly, you hit supercompensation, arriving at a brand new, higher baseline of power. But be careful. Push too hard without enough rest, and you enter overtraining, where the whole system just fails. Building right on top of that, we get the fitness fatigue paradigm. Every single training session generates two totally separate after effects, fitness and fatigue. The magic trick here is that fatigue actually dissipates at a much faster rate than fitness does. So managing your programming is all about timing your rest so that the heavy, performance-suppressing fatigue drops off right in time for game day. That leaves the athlete with elevated fitness and peak preparedness to go out and express all that power. To actually manage that super complex dance of fatigue and fitness over time, we have to break training down into digestible, hierarchical buckets. We zoom all the way out to a multi-year, 4-year Olympic macro view. Then we'll zoom into the annual plan. Inside the year, we have mesocycles, which are blocks of 2 to 6 weeks, targeting a very specific trait. And finally, the microcycle, zooming all the way down to the daily and weekly scheduling of those individual training sessions. So how do we actually arrange those blocks? Generally, we're looking at two approaches. Novices can use a parallel approach, training strength, speed, and endurance all at exactly the same time, because honestly, when you're just starting out, almost any stimulus makes you better. But as athletes become elite, that parallel approach is a one-way ticket to an overtraining disaster. Advanced athletes absolutely must use a sequential block approach. They train targeted abilities one after another, say a block of heavy tissue development, followed by a block of maximal force, and finally peaking with a block dedicated purely to high-velocity power. So as we wrap up this explainer, I want to leave you with a real question to chew on. Knowing everything we just covered, knowing about the 245 trillion cross bridges firing in the muscle, the absolute necessity for precise force plate testing, and that delicate balance of the fitness-fatigue paradigm, how are you going to apply these sports science principles to rethink your own playbook? How will you structure your next sequential training block to maximize supercompensation and truly unleash your athletic power? Take a hard look at your current microcycles, adjust those loads to hit that sweet spot, and just watch the data transform. Catch you next time.